Okay, so where we left off at the last video was looking at example 2 for electric potential difference. Okay, and the question wants you to find the total electric potential difference at the fourth corner of a square whose sides are 1.5 meters long. And the charges at the other three corners are 5, 8, and -6. And hopefully you remember in math that when you're putting things on the corners of polygons, you start at one corner and you go in a circle around, like you don't hop back and forth. So it doesn't matter which one you put the 5 microcoulombs on, but then you go around the polygon, around the square. So the 8 becomes the next one, and then the -6. So it wants the electric potential difference at this point from these three. In other words, it's asking you for the total, as opposed to example 1 that was asking you for the difference between them. Okay, so first step, you need to find VA. It's equal to KQA over R. So 9 times 10 to the 9th Newton meters squared per coulomb squared. 5 microcoulombs, 5 to the -6. And the R is 1.5 meters. Okay, and when you do this for A, you get 30,000 volts. Then you do it for B, KQB over R. So 9 times 10 to the 9th Newton meters squared per coulomb squared. B is 8 microcoulombs, so 8 to the -6. And the R is this length, 1.5, take this one, 2.1212. And when you do this, you get 33,941.1255 volts. And then you do C, KQC over R. 9 times 10 to the 9th Newton meters squared per coulomb squared. -6 times 10 to the -6. And back to 1.5 meters. And this one gives you -36,000 volts. And so now the question wants the total. So it's just VA plus VB plus VC, keeping the negative sign. So 30,000 plus 33,941.1255 plus a -36,000. Okay, so you have to keep the negative sign there. And when you do this, you should get a V total of 27,941.1255 volts. You are done. Okay? So much easier than when you were doing the electric field at a point or a force at a point, because those were both vectors, and so you had to figure out directions. But when you're doing it for potential difference, for voltage, they're scalars, so you can just add them up. It doesn't matter if they're at angles or not. And that's why potential difference is so nice. All right, example number 3 is not there. Somewhere, though. So example number 3. Here's the picture. 2 charges. One is 4 microcoulombs. The other is -9 microcoulombs. And they are 12 centimeters apart. And it says find the 2 locations on the line connecting them where the total potential difference would be 0. So because one's a positive and one's a negative, one's going to have a positive voltage, the other's going to have a negative voltage. So somewhere on this line between them, there should be a point where those 2 voltages will add together to give me 0. It should be closer to the one that's smaller in magnitude. Okay? So if you think about it, what we're saying is V1 plus V2 should equal 0. So KQ1 over R1 plus KQ2 over R2 should equal 0. And what I just said was it should be closer to the one smaller in magnitude because if it's smaller in magnitude, the r is going to have to be smaller, because really this is telling us kq1 over r1 is equal to negative kq2 over r2. The k's can cancel, and so if these two are going to be equal and q1 is smaller, well then r1 has to be smaller as well. So this is my r1 and this is my r2. And so it looks like we have two unknowns, but we really don't, because r2 is just going to be equal to 12 centimeters minus r1. So if I go down here, then this is q1 over r1 is equal to negative q2 over 12 centimeters minus r1. And now I only have one unknown. I don't have to change the 12 centimeters to 0.12 of a meter. I can leave it in centimeters because I'm just looking for a distance, and it's okay if I get that in centimeters. So cross multiply. So negative q2r1 will equal q1 brackets 12 centimeters minus r1. Multiply through by your bracket. So q1 times 12 centimeters minus q1 r1. And now you're trying to solve for r1, so I'd bring this guy over. So it'll be q1 r1 minus q2 r1 will be equal to q1 times 12 centimeters. Pull out your r1, so it's q1 minus q2 equal to q1 times 12 centimeters. Divide by q1 minus q2. So q1 times 12 centimeters divided by q1 minus q2. Fill in your numbers. q1 was my 4 microcoulombs times 12 centimeters divided by my 4 microcoulombs minus a minus 9 microcoulombs. And again, I didn't change my microcoulombs because look, you're going to have microcoulombs on the top, microcoulombs on the bottom. They're going to cancel. If you want, you can put times 10 to the negative 6 in for all of these. They're still going to cancel. When you do this on the top, you're going to get 48 microcoulomb centimeters. And on the bottom, 4 minus a minus 9 should be about 13 microcoulombs. Do the dividing and get an R1 of 3.692 centimeters. And that will be towards number 2. And therefore, R2 is equal to 12 centimeters minus R1. So R2 will equal 8.308 centimeters, and that'll be towards number 1. Why am I saying that? Well, like, if I just say 3.69 centimeters from number 1, it could be this side or the other side. So I'm saying it's on the side where R2 is. Now this question, though, asked you to find the 2 points. The 2 points. So there's a second point on the line that connects them. So here's my line. Stay still, page. My line that connects them. There's a second point, and it's always going to be on the side of the smaller one. Smaller in size, not in negative positive, right? So don't say, no, it should be on the negative 9 sign. We're ignoring the negative sign. It's always on the side of the one that's smaller in magnitude. Okay, so it's going to be some point out here. So this will be my new R1, and this will be my R2. So this time, my R2 is going to be equal to 12 centimeters plus R1. But now we're going to do exactly the same thing. Now, you might say, how come? So you need to think about the electric field around number 1, right? As it goes out in all directions, it gets weaker. And the electric field around number 2, as it goes out in all directions, it gets weaker. So because number 2 is a bigger charge here, right, as it goes out, there's going to be a point here that we just found that it's going to match number 1's. But imagine that it continues to go out and it passes over 1, and as it continues to spread, there's going to be another point on the outside of the smaller one where the two of them will be equal. Okay, and so again, it'll be V1 plus V2 equals 0. We're going to run out of time and come back, but we'll be at minus Q2 over R2. And I'll see you momentarily on the next video. Okay?